Hello YouTube, this is John from Vulgar Kitten Studios and welcome to episode 2 of How to Make a Video Game. And what we're going to be doing in today's episode is we're going to start moving around in our level. So let's go ahead and open up Unity and go into first we need to go into our scenes folder and open up our level 1 scene. If you haven't already saved your main menu scene, go ahead and save that now. And we'll go into scenes and I'll save that over our main menu scene. Make sure it's called main menu. Make sure it's played again. Didn't actually save before I started recording this one. Okay, there we go. And now we have a blank slate. Okay, so let's grab our level 1 prefab and just drop it in the scene. And then I'm going to reset its position. I'll come over here and we'll check it out. And we'll also need to set it up for our camera. And if you'll remember from the reference video, our camera was top down, so I need to maybe do this and maybe I can get a camera preview. Camera preview doesn't seem to be working. That's okay. I'm going to go into isometric mode and I'm just going to make this a top down view and try to get it as close as possible. So I'll rotate this around and play the game. Definitely not like that, so we'll need to bring it up. Maybe rotate it forward just a little bit. Well, I can just go over to the game, I guess. And let's move it up this way, maybe to about right there. And we're getting a little better. Let's zoom it back in just slightly. Can be very arduous work. And there we go. So that looks probably about right. So let's go ahead and get some lighting in here. I'm going to create other directional light and I'm just going to call this lighting. And I'll reset this as well and rotate that 30 on the x-axis. And so now our scene is lit appropriately. One more thing I want to do is I actually want to change the color of the camera. That's why my camera preview wasn't showing. I have to actually expand the camera component. Okay, so I'm going to change the color of our scene as well, our background to black. And that should do it. Let's go ahead and grab our player prefab and set him up. So, player, we'll want him to start probably somewhere around in here. Press F to zoom in on him. Right click and use WASD to move around a little bit, which works better in perspective mode. Just try to get that positioned right above the floor. There we go. And go back into orthographic and we'll give him a character controller. So we'll go to physics and grab a character controller, reduce the height to 0, and I'll set the center to 0.25 just so it touches the bottom of the wheels, and drag the Z over probably to about a 0.1, 0.2, or negative 0.1. That'll do it. And there we go. So now I'll go ahead and take our turret and I want to attach a script to it. Well, first I can foresee an error here. Because of the rotation pivot, this origin point that we're looking at with the handles, that's going to make the tank, it's the tank part, or the turret part of the tank, be way up here. So we'll just go ahead and drag that down and make that flush with the tank. Maybe bring it back just a little bit. Well, yeah, that's good, I guess. And I want to apply that to the prefab. And we'll probably need to do that to our enemy too, so I'm just going to go ahead and do that. So I'll grab that and position that right on top. And just get rid of our enemy. In the turret, I'm going to take our look at mouse script and I'm going to put that on there. So let's go ahead and play the game. And we're not getting anything from the turret. So I'm going to disable this animator because we're not going to need that. And because of the speed. And the higher you put the speed, the faster it'll look at the point, and we want it to be like instantaneously. So we'll put it up at something like 300. 300 will work good. And we'll move our mouse around. It looks like it's looking at us pretty well. So I'll go ahead and stop the game. Just make sure we apply the changes to our prefab. And we'll go ahead and create a new script. So I'll create a new script under scripts. And I'll call this player motor. And we'll open that up. And actually, before we do this, I'm just going to go ahead and make our custom cursor too, because we want to replace this mouse reticle with an actual reticle. So I'll go back into scripts and I'll create a new C# script and call this custom cursor. And I'm actually going to drop that on the main camera once it compiles. So custom cursor on the main camera. There we go. And go into monodevelop. I'll just find it in the folders in the solution view. So custom cursor. And we'll need a reference to the cursor that we want to use. So we'll say public texture 2D. And we'll say that custom texture. And we'll need two public values for the width and height of the texture. I'll make those integers and I'll make them called X and Y. And by default I want them to equal 64 by 64 because that's the dimensions of our texture. And that is really a good dimension that you want to target for a cursor texture if you're going to make one yourself. And lastly, we'll need an event variable, and we'll call that E. And it's probably not the best name in the world, but you know, it's okay. It's a short script, so we know what it's doing. So we'll change this to onGUI. I won't bother with the comment. I'll just get rid of it. And in our start method, we actually want to set our screen.showCursor equal to false. And in onGUI, we'll say E is equal to event.current. And we'll GUI.draw texture, and the texture we want to draw is going to require a new rect, and we'll position it at e.mouse position.x minus x multiplied by 0 or 0.5f. And the reason that we do this is we need to make sure that our pointer is going to be in the center of the texture, because by default it'll be anchored somewhere over to the left. So the bottom left hand corner of your cursor is actually going to be the clicking point, and you don't want that. So we'll say e.mouse position, not modifiers, dot mouse position dot y minus y multiplied by 0.5f. And for the width and height, we'll just say x and y. And we'll have to pass in our texture, so we'll say custom cursor texture. And we'll go back over into Unity and grab our main camera. Go into textures, GUI, grab your reticle and put it on the custom texture field. Play the game. And yes, when we click on the screen, I don't know if you can really see it there because of my screen recorder, but here it's actually hiding the cursor from my view and replacing it with our reticle instead. Okay. And now we'll go ahead and write out our player motor script. And this is going to get a little bit complex. Not all of the methods I even completely understand myself. I'm actually going off of a tutorial that I watched from John Mack about a third-person character controller. I've just modified it to make it my own. And first thing that we'll need is a reference to our camera, so we can make a referential shift in the transform between our camera's transform and our own transform as the tank. And so we'll say public float, and I'll call this rot speed per second, and set that to 120 f by default. And we'll need another one, which is going to be the actual rotation speed, and make that equal to 20. And we'll need a move speed, and make that equal to 5. And we'll need a couple of private floats, one for our horizontal axis, one for our vertical axis, one for speed and direction. And we'll get a reference to our character controller and call that CC. And then start, we'll just set that component. So we'll say CC is equal to get component character controller. And in update, we'll want to go ahead and set our H and V variables to be equal to our input. So we'll say input.get axis, and the axis we want to get is horizontal and vertical. Like that. And we'll need to set our speed to be equal to the square magnitude of our input. So we'll say a new vector 2, H and V, and get the square magnitude off of that. And now we'll go ahead and write out our shift between our camera and our object. So we'll need to superimpose our input into the screen space. So we'll say void and rotate towards input. This will accept a transform, which will be the root transform for the camera, and we'll reference the float direction, and we'll reference the float speed. We'll need to make a new anonymous vector 3 here and call this root direction, and we'll just cache that to be equal to root dot forward. And then we'll make another vector 3 and make this our input direction, which will be a new vector 3, and we'll set that x to be h, 0 for the y, and v for the z. And we'll need to set our speed out, so we'll say speed out is equal to input direction. I didn't put the the suffix on our variable here. Input direction dot square magnitude. Okay. And we'll need to get our camera's transform, so vector 3 cam direction is equal to cam dot forward. And we want to kill the y, so we'll say cam direction dot y is equal to 0f. And we'll use the quaternion from to rotation to actually create a rotation, so we'll say quaternion referential shift is equal to quaternion dot from to rotation, and the from rotation will be vector 3 dot forward, and the to rotation will be our camera's rotation, or camera's direction. And we'll say, well, I believe I've forgotten a variable, so I did actually forget our move direction. We want to cache a vector 3 variable and call this move direction. And in here we'll go ahead and set that, so we'll say that our move direction move direction is equal to referential shift multiplied by our input direction. And here we're multiplying two quaternions, so it's not the same as regular multiplication. Then we'll get the sign of our values, so we'll make a new vector 3 and call it sign, and that's equal to the cross product between these two vectors, and we'll use, or not, angle dot cross between our root direction and our move direction, and we'll multiply that by our sign, or no, we don't need to multiply that by anything. Getting ahead of myself there. Alright, so we've got our sign, our cross product, and now we'll create a variable called angle root to move, and that is equal to a vector 3 dot angle root direction and move direction, and we'll multiply that by our sign dot y greater than equal to 0, and here we'll actually perform a ternary operator, which is the same thing as an if statement. So we'll put a question mark, and if it's less than, or if it's -1, or if it's +1, then that's what it'll actually return on. So just in case you've never seen a ternary operator before. And we'll use our angle root to move and multiply that by 180 to get the hemisphere, and set our direction out is equal to angle root to move multiplied by rot speed. And if our move direction does not equal vector 3 dot 0, then we'll set our transform dot forward to be equal to vector 3 dot lerp, and we'll lerp between our current transform dot forward and our input direction over our rot speed, and we'll use time dot delta time to smooth out the frame rate. And otherwise, because we don't want to be holding our input to the left and then let go and then start looking forward again, otherwise we want our transform dot forward to be equal to itself. Alright, so we'll go back into update now, and we'll call this method rotate, or not rotate drive mode, rotate towards input, and we'll use our transformer as our root and our camera as our camera, which I prefix that with a underscore. I don't normally do that with our public variables. And reference the direction variable, and we'll also reference our speed. Okay. Finally, we'll move our character controller, we'll move our character controller. We'll say cc dot move, and we'll use move direction for the vector that we want to use times move speed times time dot delta time. And also, just to be on the safe side, we're not actually going to be doing any Y movement in our game, but I'm just going to make sure that we never ever actually can go over objects. So I'm going to apply some fake gravity to this, and I'll say move direction dot Y minus equals 20, or actually we'll expose the variable gravity equals 20. Gravity times time dot delta time. And so that way it can never, or it will always be on the ground. And so after we've moved our controller, we also need to perform some logic to rotate our player appropriately. So we'll say if our direction is greater than or equal to 0 and our horizontal input is greater than or equal to 0, or if our direction is less than 0 and our horizontal is also less than 0. So this will only perform if we're either going left or right. We'll create a vector3, we'll say rot amount is equal to vector3 dot lerp, and we will use vector3 dot 0 to a new vector3, and in here 0 for the x, rot speed per second for the y, multiplied by our input, which is going to be, well, horizontal is less than 0f, and then perform another ternary operator here if it's -1 or +1. And 0 for the z. And finally, we'll use mathf, or mathf, dot absolute value, and the absolute value of our horizontal axis as our time. Or the time it takes to get between those two vectors, I should say. And then we'll create a new quaternion and call this delta rotation. Make that equal to quaternion dot Euler and rotation amount multiplied by time dot delta time, and we'll set our transform dot rotation to be equal to transform dot rotation multiplied by delta rot. And let's go back into Unity and see what this error is. Can.y. So to make that a transform can. Okay, so I'm not actually supposed to be using cam here. It's going to be camera direction, the vector that we calculated, not the actual transform, because that's the float y is protected and you can't change it directly through script. So that's why we stored it in a variable. Okay, so we'll go back into Unity. And we got our custom cursor on our main camera, so we'll go back onto player and drag our player motor on there. And let's go ahead and play the game. Well, we can't do anything right now because we haven't actually referenced our camera, so we'll take our main camera and drag it on our cam variable in the inspector. Play the game, and we're going pretty fast, so we'll change our move speed to probably about a 1.5, and that is a lot more sensible. But now we can actually rotate our body in any direction, and so right now I'm hitting up and now I'm hitting down, and it'll actually rotate. So this gives it a little bit more realistic movement than using just the regular character controller method. So like I said, I don't completely understand all of the referential shift math that's going on there myself, but there is a tutorial from John Mack. It's called Unity 3D Mechanism tutorial, or Unity 3D third person mechanism tutorial, or something like that. But he explains it a lot better than I can. I'm just going to say that. Other than that, I'm going to go ahead and end this video, and that does it for episode 2, so I'll see you in the next one.